All right, guys. I'm going to be going over Unit 1, Lesson 7 with y'all today. So we're going to be interpreting functions, and we're going to be integrating the transformation rules that we've been going over. Okay, so a lot of range and domain talk in here, and we'll go over that in case you forgot. But first, let's start with this. So it says, Kim and Jim are twins and live at the same home. They each walk to school along the same path at the exact same speed. However, Jim likes to arrive at school early, and Kim is happy to arrive 7 minutes later just as the bell rings. Okay? Pictured at the right of the graph is Jim's distance from the school. Okay, so first thing to know, that's my time down there. My x-axis is my time. So as we move to the right, time is passing. Okay, it says minutes after 7. So I have 7:01, 7:02, so on and so forth. Okay. I have yards up there, so that's the distance from the school. Okay. So this is for Jim. So Jim starts his journey 900 meters away, or yards, sorry. Starts at 900 yards away, and eventually, right at 0 yards, he showed up. So how many minutes after 7 a.m. does Jim leave for school? Well, the trip starts here, right? Well, guess what? My x value is 0. He starts 0 minutes after 7. He leaves exactly at 7. So, 0. How many minutes after 7 does Jim arrive school? Well, when he's 0 yards away, he's in the building. And he's 0 yards away at 13 minutes after 7. How many minutes after 7 does Kim leave for school? Well, she leaves 7 minutes later. So instead of starting at 0, right, and she lives at the same house, so it's still going to be 900 yards away, I can go from 7, bring it up to 900. Okay, so that's hers, right? We know that she starts 7. And if they go along the same path at the same time, well, this should be the exact same graph, just shifted to the right 7, right? So I'm just going to do it roughly like that. Yeah, close enough. All right. How many minutes does Kim arrive after school? Well, it's 7 minutes after Jim. He arrives at 7:13. She arrives at 7:20. What's the farthest distance for Jim from the school? Well, we established it was 900, right? That's as high as it goes. So they must live 900 yards away. What's the closest he gets? Well, he shows up, so it's 0. Kim is the same thing. She lives at the same house. She shows up to the same school. Okay? So, right here, it says we're looking for the range and domain. Okay? So just a little reminder, domain is all my x values in the function. So however far right and far left we go. Range is all the y values. Oops, I can't spell. So that's how high and how low we go. Okay, so let's look at the graph again. So Jim's domain goes from what to what? Well, the far left it goes is 0 on the x-axis. The farthest x value you have is 13. So Jim's domain goes from 0 to 13. All right. Let's talk about the range. Okay. What's the closest he gets to the school, right? We're talking about the y values now. Well, the lowest is 0. The highest is 900. So his range goes from 0 to 900. Okay. Kim's domain. All right. What's the farthest x value? Well, she leaves 7 minutes after, right? So it starts at 7, and she goes until 20 minutes after. So her domain is 7 to 20. And Kim's range, right? She lives in the same house. Goes from 0 to 900. Okay, so quick thing. Let's look at this. What does this look like? I took this, I slid it to the right. Well, it kind of looks like translation, right? Or a slide. So I could say xy becomes, well, since we're only moving right, I'll add 7 to the x value. and that y value stays the same, right? We didn't go up or down at all. Stay the same. Okay? So, this part on the bottom, okay, this part on the bottom talks about writing it in interval notation. That's the way I like to do it. So, really, we're just going to be using brackets here. So, 0 was our lowest number, 13 was our highest number for a domain. I'm going to put a bracket, put a 0, comma, 13, bracket. So in between the brackets, you have your lowest number, a comma, and then the highest number. Okay? So talking about the range, well, my low number is 0, my high number is 900. Okay? Talking about domain again, we go from 7 to 20, right? Low number, high number. And for 13, we go from 0 to 900 again. Okay? All right, so these are the way I like to write it. Sometimes they'll ask for it like this. All right, you're always going to have these less than or equal to symbols for this lesson. And you make a little sandwich, right? X is for the domain, Y is for the range. X domain, Y is range. Okay? But let's focus on that. All right, we'll flip the page over. Flipping that page over. Let me get it sorted out. Cool. All right. So, it says, given the following graph, state the domain of the preimage and interval notation. Okay, I know this is the preimage because I don't have these little apostrophes, right? A prime, B prime, C prime, right? So I know this is the preimage. What's the furthest left it goes? -6. What's the furthest right it goes? 0. All right, let's talk about the range. What's the lowest y value? Well, it's 0. What's the highest y value? 3. Okay. All right, state the domain and range of the image in the interval. Okay, sorry, Jesus. All right. We're going to state the domain of the image, right? The new one, okay? So, looking at this figure, right, we switch it, or we slide it to the right and up. So, if you count, we'll slide it to the right 5. We're going to go up 4, okay? So, that's kind of the rule, right? Well, guess what? Let me find that domain and range real quick. It goes from -5, or sorry, -1 to 5. My range goes from 4 to 7. All right, I can find it from looking at the graph. We'll see how it says x plus 5, right? We moved to 5. Well, what's -6 plus 5? Well, it's -1. What's 0 plus 5? It's 5. So I can add that 5 to both extremes of my domain. Okay, so we're going to be able to apply these transformation rules to my range and domain to find out what it looks like. All right. We went up 4, right? So we're adding 4 to the y value. Oh. So if I add 4 to 0, I get 4. If I add 4 to 3, I get 7. Okay? All right. Let's look at this one. It says, draw and label the image of AB translated 2 to the left and 3 down. Okay, so left 1, 2, down 1, 2, 3. That's my A prime. Left 1, 2, down 1, 2, 3. That's my B prime. Okay? All right, so I can look at this. All right, we start at 1, 4 for my preimage. All right, the lowest we go is 1. The highest we go is 2 for the y values. Okay, so left 2, down 3. X minus 2, y plus 3, or sorry, y minus 3. Okay? Guess what? I didn't necessarily have to graph it, because if it's left 2, I'm subtracting 2 from both of these. I get -1, 2. Okay? If I'm going down 3, that's y minus 3. So from the range, I can subtract 3 from both of those. Okay? And I get -2, -1. All right? Now, it says draw and label the image of AB reflected over the x-axis. Okay, so this is my x-axis, right? So let me highlight that real quick. So I can flip it around. Let me see. I want that color. Okay, so if I move down 1, I can just double it up, and there I go. If I move down 2, double that up, there I go. So that's my A prime, that's my B prime. Okay, so we start with the same domain and range. 1, 4, 1, 2. Well, what's the rule for when we're flipping around the x-axis? Okay, it is xy becomes x negative y. Okay, so x and x, right? The x's don't change. Well, guess what? My domain doesn't change either. 1, 4. Okay, y becomes negative y. So what I do is I just change these numbers to negative. So instead of 1, I have negative 1. Instead of 2, I have negative 2. And for this, we have to put them in order. Okay, so I have to put my lowest number first, my highest number second. Since negative 2 is my low number, I'll put that first. Since negative 1 is my highest number, I'll put that second. So the domain changed because the domain stayed the same because my x stays the same. The range changed from positive to negative, and it's not necessarily negative, right? This negative y means I'm just switching the signs. So since I switch the signs, instead of 1, 2, I get negative 2, negative 1. All right? Flipping over the y-axis. Okay, I'm not even going to graph this one. So we start out with 1, 4 and 1, 2. And flipping over the y-axis, I get xy becomes negative x, y. Okay? All right. The y stayed the same. Guess what? My range is going to stay the same. 1, 2. The y changes signs. So instead of 1, I get negative 1. Instead of 4, I get negative 4. This is my new domain. I got to flip it to put it in the right order. So I get negative 4, negative 1. Cool? Awesome. All right, flipping it around. Okay, kind of printed off a little funky, but we're going to do the same thing, but flipping over the line y equals x. Okay, so same domain, same range. Let me flip this over on my part. Ooh. Okay, same domain, same range. So I go from 1 to 4 for my domain. I go from 1 to 2 with my range. Okay. What is the rule for flipping over y equals x? Well, xy becomes yx. All right, and you can graph it if you want. I don't want to. I want to do it the easy way. Well, if my x becomes the second one, right, I'm kind of just flipping the order. Well, guess what? I'm flipping the order of the domain and the range. So my domain is now 1, 2. My range is now 1, 4. Okay, we're applying those algebraic rules to the domain and range. Okay, draw and label an image AB over 90 degrees. All right, it doesn't tell me what direction, so I know it's counterclockwise. Okay, it says state the domain and range of the preimage. So let's do that again. Okay, cool. All right, my rule is xy becomes negative yx. Okay, so I know that I started with my domain, now it comes second, so it's my new range. So I'll bring 1, 4 over here. I flip the range over to domain, but since it's negative y, I have to change signs. I cannot spell. There we go. Cool. I gotta change signs. All right. So I have 1, 2. So now I have negative 1, negative 2. And let's flip it around because we gotta put in the right order, right? Lowest number first. Highest number second. That's my new domain. That's my new range. Cool. All right. Now we're dialing by a scale factor of 3. So we got 1, 4 again. We got 1, 2 again. Well, what's the rule for dialing by a scale factor of 3? Well, I just multiply my x values and my y values by 3. Okay? So 1 times 3 and 4 times 3. Okay? 1 times 3 is 3. 4 times 3 is 12. All right? Times 3. Times 3. 1 times 3 is 3. 2 times 3 is 6. I knew that. Okay, cool. So we're applying those algebraic rules, all right? Okay. I'm going to do one of these examples. So this is the worksheet y'all are going to work on. Okay, let me break that down. So you guys can do the graphing part. All right. If you want to, you can graph these each out. I don't feel like doing that, okay? One thing I do want to show you, okay? You can look at these coordinate points and find the domain and range without graphing it, okay? So domain is my x values. I got 2, I got 1, and I got 4. All right, what's the lowest number out of all of those? It's 1. I put that first. What's the highest number out of all of these? It's 4. I'll put that second. All right, same thing with the range, okay? Let me change up my color. All right. What's the lowest y value I have? Well, I have 5, -1, and 2. Well, -1 is that low number. 5 is the biggest number I have. It goes from -1 to 5. Okay? All right. You guys are going to be working on this. And yeah. Can you rewatch the YouTube video? Right? Guys, listen. When I was in school, I had a hard time paying attention. I would often go home and look at YouTube videos to help me with the things that I kind of missed when I was staring off into space, okay? There are a ton of resources out there, all right? You got Mr. Cup in third. You got a great sub. But if you need a little extra, right, go online. Check it out. It's all good, okay? All right. Hopefully that helps, and I'll catch you guys later.